Hello, today we are going to set up KDE-builder, which is the KDE framework for building KDE Git repositories and KDE source code on the Linux operating system Fedora KDE 41. So let's get started. This is a fresh installation of Fedora KDE 41. We go to the official KDE website, kde.org. We click on Get Involved. If the screen is not large enough, then the main menu of the website kde.org is hidden behind this hamburger menu. Get Involved. We scroll a page down towards Development. In here it says that if you want to start programming for KDE and if you want to build KDE software and from source code, and especially from the KDE Git repositories, it's a good idea to use one of these operating systems, which will have a new enough version of the Qt framework and the new enough versions in the binary packages repositories for this Linux operating system for other software which is not part of the Qt framework or part of the KDE project. Fedora KDE also is one of these operating systems. So I have the latest version of Fedora KDE. Next step is to install the KDE builder build framework. The build framework KDE builder has replaced the previous framework, which was named KDE src-build. What does KDE builder do? For a given KDE Git repository, it knows how to fetch it, so how to do the git clone and other Git operations, in which order KDE Git repositories must be built. For instance, if you want to build a KDE Git repository kconfig, that will depend on the KDE Git repository extra CMake modules. So KDE builder will know to git clone, configure, build, and install the KDE Git repository extra CMake modules before doing the same for the KDE Git repository kconfig. So KDE builder knows the dependencies between projects and also knows for each project how to actually build that project. By building, we mean take care of the dependencies, then do git operations, then do configure step of CMake, then do build, which is nowadays Ninja, and then do install, which is nowadays Ninja install. Let's set up KDE builder. We have large enough storage. So we have an SSD that's 300 gigabytes in size, a virtual machine, 14 vCPUs, 10 gigabytes of random access memory. The KDE source code is C++, so it requires beefy hardware resources. We'll start the KDE terminal, which is the application console. We'll have the documentation take half of the screen, the right one, the right half of the screen, and the work, which is console, the left half of the screen. This command line will download a file from the KDE Git repository KDE builder. The file is named initial setup. Then it's running that initial setup.sh file using bash, not your favorite terminal shell. So not zsh or what do you use, but bash, because initial underscore setup.sh is a bash script, not a shell script. It will install binary packages from your Linux operating system, such that KDE builder can run, because KDE builder is a Python script and project. Yes. So it installs Git. It installs a Python module, set proc title. Okay, and at the next step, we are required that kde-builder can be invoked without specifying a full path or a relative path, which means that kd-builder must be in the path environment variable. So let's see that. So which kd-builder, and the kd-builder was sim-linked to the tilde/.local/bin/kd-builder, and tilde/.local/bin is in the path environment variable. If kd-builder is not in, if the directory tilde/.local/bin is not in the path environment variable, and it should always be for Fedora, maybe you need to reboot your computer. Okay, so the path environment variable actually starts with tilde/.local/bin, which means we can run this command. Okay, this says that it has created a configuration file, this one, in tilde/.config/kd-builder.yaml. I would like to have Kate available here. And it says if I want to install the package Kate, which I actually do. Okay, so Kate, and now I can either copy and paste, right click and then paste, or I can just select and middle click. So middle click is, in my case, I have a mouse with a left button, a right button, and a scroll wheel. So I'm going to click on the scroll wheel. Why is it asking me a ton of times? Says I'm not authenticated. Okay. So it wants me to do this. From what I see, there is a bug in Fedora 41 where if you write a command which is not installed, it offers to install the package Kate, but doesn't do so prepending the command line with sudo. So it should not suggest that I run dnf install Kate, but that I run sudo dnf install Kate, because as it is, it's useless. So it should ask for the sudo password for the current user. Otherwise says waiting for authentication, failed to install packages, failed to obtain authentication. Which is also wrong because I have provided the password for sudo before, and when I ran the command line sudo dnf install Kate, it actually did not ask of the password, so it uses a cached version of the password. Okay, let's look at the configuration file. I know how the configuration file should look like, and this line 6 is okay, line 12 is okay, the directories are okay. I want this thing to be actually debugged because I want to run the debugger. 14 CPU threads, that's the exact number that I have on this computer. Stop on failure true, directory layout flat, and cmake backend generator ninja. Okay, the configuration file looks okay. The only thing that I did change was change the cmake build type from rel with debinfo towards debug. But if you're not using a debugger such as GDB or the integrated development environments, Qt Creator and CLion for debugging purposes, then you can leave it at the default version value, which is rel with debinfo. So if you just want to build KDE software and test it. run it. Okay, these collapsible parts is if you don't have tilde/.local/bin in your path environment variable, and support for doing advanced queries using apt or DNF, the command line package manager for your Linux operating system. These instructions are only for the Debian family of Linux operating systems. So it does not apply to Fedora. Fedora is a different family of Linux operating systems, along with the Red Hat Linux Enterprise, and it's the clones of Red Hat Enterprise Linux. Next up, this command, which installs distro packages. So this will install 1000 RPM packages on your Fedora KDE 41 Linux operating system. I want to continue. What's installing in here? It's installing the newest version of Qt 5, most of the Qt 5 framework RPM packages, most of the Qt 6 framework RPM packages, all of the dependencies of the Qt 5 and Qt 6 RPM packages that it installs, and then all of the RPM packages which are needed in order for the KDE Frameworks version 5 and KDE Frameworks version 6 modules to be built from source. So very large list of RPM packages, and also a large list of RPM packages with names that end in -dvel. So there's -dvel RPM packages for compression, like zipping algorithms, for image encoding and encoding, for instance, for PNG, video encoding and decoding, audio encoding and decoding, fonts. What else? Hashing, numerics, the boost, C++, libraries, hardware acceleration libraries such as GL and Vulkan, and a ton of Python modules, a ton of Perl modules. We'll be back once kde-builder finishes installing all of these packages using DNF space install. Okay, so that was really quick. DNF 5 here probably. So it says that kde-builder has been installed and configured correctly. Now that we have a working installation of kde-builder, let's see what's next in this manual page. In the page on how to install, says once in a while you want to make sure that kde-builder is up to date. kde-builder is up to date because we have just installed it. Then it talks about the Qt version, and we require Qt version 6.7 or greater, and Fedora KDE 41 does have this thing. So let's actually see the version of Qt. RPM-QA lists all of the installed packages. In here we'll grab for Qt and for 6 and for devel, and we're looking at the base, for instance. Oh, that's a ton. So Qt 6, Qt base devel, version 6.7.2, which is greater than or equal to 6.7.0. So we're all good. Then it says that if you want to write to the KDE Git repositories, you need to configure Git. We don't want to write to the KDE Git repositories. We want to just read from the KDE Git repository, so that's okay. And then it says that you want kde-builder to move as fast as possible. So that means, if possible, disable for at least the directory ~kd all of the tools which look for files and will slow everything down, such as file system, search and indexing, antiviruses, any other such software which runs in the background and listens for files which got created or deleted or changed. We want to actually check this thing. Let's search for file search. Says that file search is enabled. In here you can do two things, either disable file indexing altogether, or you can do what's shown in this screenshot. So go file indexing enabled, yes. Data to index file names only, I'll go. And then it says in here, nothing is indexed from the home directory except documents, music, pictures, and videos. So that's a good enough setting, does not affect the directory ~KDE where we will work, where we will create a ton of temporary files and build files. So actually we can keep everything as is. Don't save anything and close the system settings application. Discard. Next up, we want to actually use kde-builder. We're going to start a new console, not needed, but we're going to show how to start using kde-builder. For instance, maybe you rebooted your computer. kde-builder, as we saw, is already in the path. And we can start running it. I always build applications using kde-builder in the exact same way. First of all, I'm going to build just two KDE modules, the two KDE Git repositories, to make sure that kde-builder was installed correctly. And that's kconfig. So kconfig is a KDE frameworks version 6, which depends on just one other KDE Git repository, which is ECM extra CMake modules. By building just kconfig, I make sure that the correct RPM packages were installed by kde-builder, that we have enough of the C and C++ toolchain applications and packages installed, I know CMake and Git and G++, etc. Ninja. So this should be pretty fast. I have 14 CPU threads. Ninja is going to use all of them. After I finish building kconfig, which again is a small test to make sure that kde-builder was installed and configured correctly, the next thing that I want to do is to build the KDE graphical user interface application kcalc, which is this thing, the desktop calculator. While kconfig is finishing installing, I'll install a file manager that I use, which is called Crusader. This is just for my ergonomics. So sudo dnf install Crusader. Yes. This is the initial setup of Crusader, which you should ignore. So don't mind of me clicking a ton. Is it -r /bin/ and that should be it. This is a Qt 5 KDE Frameworks 5 application. So it will need some packages installed which use Qt 5 and KDE Frameworks 5. Probably this one. The default where DNF install sometimes offers the default answer to be no is not that great for me. Okay, let me configure a bit Crusader. I need a console version 5. And it's probably this guy. Why again? Okay, and hopefully now I can do that. Show embedded terminal. Okay. I'll restart Crusader. I'll pin it. And that's what we have. It is using a strange color scheme. It's a Qt 5 and KDE Frameworks 5 application, whereas the rest of my desktop KDE Plasma is version 6 and uses KDE Frameworks version 6 and Qt 6. Okay, where we were. So we wanted to see what kde-builder space kconfig just did. So in the configuration file says that there are 3 directories or 4 inside ~/kd. So kde-builder doesn't touch the exterior of ~/kd, it does not install software in the /usr, which would require elevating as the user root. So kde-builder only touches this directory, ~/kd. In here it clones KDE Git repositories, it builds software, and then it installs software. Doesn't even touch ~/local /bin. So it doesn't install in here a million of KDE executables that you have just built from source. The installed directory is this one, ~/kd/usr. The binaries are in the bin directory, the libraries in the lib directory, the .h files in the ~/kd/usr/include directory, etc., as you would expect. src is the directory where git clone operations happen. So extra CMake modules was git cloned in here. Let's see, git remote -v. So this is a git clone directory. We can see that because we can see the git fetch and git push URLs. It uses a remote which is named origin. Let's install git GUI. So these two are graphical user interface executables from the official Git project. Git GUI. So we saw the remotes are this one, remote origin, but with two different URLs. We can see that the local master branch points to the same Git commit as the remote origin master Git branch, which is what we want, what KDE-builder ensures. If you don't specify any additional command line parameters, KDE-builder will make sure that it builds software as it exists in the KDE Git repositories. If you do local changes, it will try to overwrite your local changes with what's in remote origin master. So be sure before running KDE-builder without the command line parameter which says don't touch my source code changes, because you might lose source code changes. The same for the kconfig git clone. So in the directory ~kd/src/kconfig, in here is a git clone of the Git repository. And first of all, it built this module. So that means creating this directory ~kd/build/extra-CMake modules. The name of the directory is identical to the name of this directory. The full path of the directory is different. Contains build in the full path, whereas this one contains src in the full path. So in here, the CMake configure and build took place. And then from here, files were copied to the installation directory at this step where it says installing. ECM, most of the files are in here. ~kd/usr/shell/ecm/cmake. Okay, the same for kconfig. It was git cloned in here. A temporary directory was created in here. In here, the build took place. So that's the steps: preparing build system, removing files in build directory, old build system cleaned, start new build system, running CMake configure in order to generate Ninja files, which the Ninja file is probably this one, build.ninja. Which is a pretty flat file which contains build targets and the dependencies between build targets, similar to a make file. And then the compile step tells Ninja to use this configuration file to build. So it creates build artifacts, which is .so files, and these are executables. Most of the generated executables are actually tests, the ones with test in name either at the end or at the start. If it's an executable and has test in the name, then that's there for the tests of that module, which test use the C-test testing framework and Qt test. And then the binary files and other files were copied from this directory at this step installing kconfig succeeded, this one, into the install directory, which is ~kd/usr, and then in bin there's two executables, In lib, there's many SO files and their symlinks. So there's this file, libkf6config core.so.6.8.0, and then a symlink from .so.6, and then a symlink from .so. There's a QML module, etc. Include files. So these are .h C++ files. So now we know how a module is git cloned and built and installed. We know that KDE builder knows the dependencies between modules, so it knows when we tell it KDE builder to build kconfig, we know that kconfig knows to build extra CMake modules first. Okay, the next module that I always build is kcalc. This is 28 Git repositories. Most of them are from the KDE community, but there's also some Git repositories which are not from the KDE community, such as this one, which is Wayland. Let's see why it fails. Some Git operations related to this thing. It might be that, let's try one more time. So if you're looking at the errors, it went like this. It says kcalc depends on extra CMake modules and on Wayland. It doesn't rebuild Wayland. It doesn't rebuild extra CMake modules, but it builds it. So it does Git operations to make sure that the local Git master branch points to the same Git commit as the remote origin master branch. And there's nothing to do there because it actually does. Then it will do a build which is not a rebuild, so an incremental build. It looks if there exists file in the tilde/kd/src/extra CMake modules which have changed. If so, it will build those, link those, and install all of the new build artifacts and all of the change.h files, etc. Then it advances to the next module, which is Wayland, but then on a secondary thread. So there's a thread which builds modules one by one, linearly, in a serial fashion. So if once it finishes building one module, it will start building the next one. But then on a second thread, Git operations happen. So in this case, on the second thread, the Git clone of the Wayland Git repository failed. And it failed because Git returned exit status -1. Maybe a timeout issue, or I don't know exactly what. But then I ran it again, and this intermediate HTTPS glitch with a Git command line has not happened. The Git clone of the Wayland Git repository was successful, and now it managed to CMake configure Wayland correctly, build Wayland correctly, and install Wayland correctly. Then it progressed to the next module to build, which is Plasma Wayland protocols, which actually depends on Wayland and actually requires Qt 6.7.0. Then it's building other KDE frameworks version 6, such as kconfig. This was already built, so it does a build, not a rebuild, so an incremental build here. Kcore add-ons and other KDE frameworks version 6 was not built previously, so now it does a full build. K-internationalization, K-codecs, other KDE frameworks version 6, K-GUI add-ons. In total, 28 Git repositories will be built, and the exactly final one will be the kcalc Git repository. The others are libraries which are needed by kcalc. It's going to take a while. At the end, the kcalc executable should be available in the place where we expect it to be available, which is tilde/kde/usr/bin. In here should be a file kcalc without any extension. So we'll be back once kcalc finishes being built and installed. So KDE builder has finished building kcalc. Now we have the executable kcalc in tilde/kde/usr/bin, but we are shown these warnings. Says that Sonnet has no backend, which I'm going to actually fix by installing the devel RPM package for hunspell. So let's do that. dnf search hun grep spell grep devel. This thing, unspell devel. Already installed. Wow. Why does it not like it then? A spell, G spell, GTK spell, H spell, Hon spell, lib spell, nu spell. So maybe it doesn't complain about hun spell, maybe it complains about H spell. Let's try with this. dnf install middle click. Okay, hopefully this one is fixed. Then it says it did not find Ruby. I'm not sure for which module is this one. Oh, it says in here it's for kcalc. I'm not sure why kcalc would need Ruby. And then it says kf6 doc tools, which will probably fix by building all of the KDE frameworks. So I'm going to next build all of the KDE frameworks. This is the succession of KDE-builder invocations that I do after I install KDE builder. First is kconfig, then kcalc, then frameworks, then plasma minus integration. And I'm running kcalc twice. First before building plasma minus integration, and then after building plasma minus integration. I can run kcalc just by double clicking like this, or I can start it using kd-builder. Command line parameter -- run. Like this. In this case, the application kcalc has started correctly, but it's loading some SO files from /usr. And I want all of the from KDE. So the executables that we build using KDE Builder should find all of their libraries in ~kd/usr, not in /usr. Including the themes should be from ~kd/usr, not from /usr. Let's prove that that's the case. ls off. Does ls off work? Let's pause the build for a second. Okay. And we're putting this in a text file. So ls off list open files looks at all of the files which are opened in various processes. In this case, grabs by kcalc, so it shows only the files opened by kcalc. And between these open files, there will be also s.so files, which are the shared libraries in Linux. Let's look at the files. So I'm grabbing by kcalc, and then I'm saving everything to a text file, and now I'm opening the text file with Kate. This in order to prove that this process runs from ~kd/usr/bin, which is correct, but then it loads many KDE SO files from /usr. Let's search for what? /k /k. So one file.so file from the KDE community comes from ~kd/usr, as we expected. The breeze icons are from ~kd/usr. We should be able to search somehow using regular expressions. Yeah, it's in here somewhere. I have no clue how to search without inventing a regular expression. So something like this. A regular expression space /usr, everything which is dot, then asterisk as many times as needed, including 0, then a k, and then anything, any number of times, and then so. It will find /usr/lib64/ libkf6 bookmarks and libkf6 solid and libkf6 completion, etc. So in my opinion, running just kd-builder kcalc and then kd-builder --run kcalc is not enough. You actually do want to build all of the KDE frameworks, and then you want to build you want to build the module +- integration. that's the spirit that we want. We want to have all of the SO files being which are part of the KDE community be built using kde-builder. In order to make sure that we're using the latest and greatest source code from all the KDE Git repositories, if that's your objective, if you want to make sure that you're running inside of this process kcalc just source code from the KDE community, which is from Git master, then that's the way to do it. Build the module that you want, such as kcalc, but also do build all of the frameworks and build the module plus or minus integration. But maybe that's not your objective, to build kcalc and all of its dependencies from KDE master branch. Maybe you're working on an application which also supports the penultimate released version of the KDE libraries, or just the newest released version of the KDE libraries and KDE frameworks. And in that case, you might be able to just get all of the KDE frameworks and libraries from a recent enough Linux operating system that actually ships the versions of those KDE libraries and frameworks. And then maybe you want to build using kde-builder just this module kcalc. And that's done with a command line like this. So kde-builder no include dependencies. But in order to build just kcalc and use the rest of the libraries straight from RPM packages, you do that in an exceptional case. So in most cases, you want everything built from KDE Git master branches. That's the default. If you start programming for KDE, that's what we recommend. But then if you start working on a specific KDE project, and the maintainers of that KDE project do tell you that they need to support older versions of the KDE frameworks or the KDE libraries, and you should use a different way of building that KDE Git repository, then do what the maintainer says. Otherwise, the default is that you want everything from KDE Git master branches. Okay, we're building another Git repository which is not part of the KDE community, GPG-ME. We're building all of the KDE frameworks, 82 Git repositories. After this finishes, we're going to do 2 more invocations. We're going to go kde-builder plasma integration. And then we're going to do the final one, which is kde-builder --run kcalc. This time we're going to check that kcalc has all of the SO files from ~kd/usr, not from /usr. This command line is wrong. So kde-builder plasma, not plasta, minus integration. This guy. And that's about it. That's it. How you start installing and configure kde-builder, and which modules and in which order you should build and run using kde-builder, in my opinion. If you want to make sure that your kde-builder is very correct and has put in ~kd/usr the files needed for most of the KDE Git repositories, such that when you run a executable created from a KDE Git repository using kde-builder, those will find most of the SO files from ~/kd/usr, not from /usr. Why would you want that? Because right now, as you saw, the kcalc application was mixing. So it was using some KDE frameworks .so files from ~kd/usr, and in there they're using the master branch, so the latest future release of KDE frameworks version 6, whereas some KDE frameworks were loaded from /usr, which come from RPM packages from this Linux operating system, which is Fedora KDE 41, which are from a release version of KDE Framework 6 and which are older. So you have two different versions of KDE frameworks loaded into the same kcalc process. So this should be it. Now it's building all of the frameworks, and then you should build Plasma integration and then run again kcalc. So this was how to install and set up KDE-builder, which is the recommended way of building KDE source code in Linux on the Linux operating system Fedora KDE 41. Thank you.